Hey guys, let's learn about discriminants. So if we have a quadratic equation and we want to use the quadratic formula, the discriminant is actually what's under the root. What's under the root? So b squared minus 4ac. And then that discriminant can actually tell us what kind of solutions to expect before then we actually completely calculate the values for the, the roots that we are looking for. So before then we even finish the quadratic formula, if we just look at the discriminant, we should be able to tell which kind of solutions to expect. And then what we need to say is that discriminant can be either positive, greater than 0, equal to 0, or negative, less than 0. So if the discriminant is positive, that means we have a positive number under the square root, which means the solutions are going to be real numbers, real solutions. And that looks like something like this. The parabola crosses the x-axis at two places. Those are your two real solutions, two real roots, right? Two x-intercepts. So if the solutions are real, then the graph has to hit the x-axis. So it could also be something like this. So the parabola is opening down, but still it hits the x-axis 2 times. So if we have the determinant that's greater than 0, that's positive, we have two real roots. Now, if the discriminant is equal to 0, if what's under the root right here is equal to 0, then square root of 0 is 0, so that will be completely gone. So we will just end up with negative b over 2a. So in that case, we will have a so-called double root. See, there is no plus minus, so that we won't really get two different roots. We'll just get one number here, and that's called double root. It's still, we can still say that we have two roots. It's just that those two roots ended up being the same number. So that could look like, let's say, something like this. It hits the x-axis and comes back. So it hits the x-axis right there. The vertex is actually on the x-axis. Or it can as well be flipped around and opening down, but still hits the x-axis right there. Okay, you can think of it this way. Like if you look at this parabola here, and you have two roots. If you pull this parabola up a little bit, if you pull it up, the two roots are going to get closer. If you pull it up some more, the roots are going to get even closer. And then if you pull it up to the point where the vertex is on the x-axis, that means the two roots actually ended up being at the same place, right? And then we can also algebraically show that there are really two roots, but they ended up being the same number. And then, so that's why we call it double root. And then the last possible option was that the b squared minus 4ac discriminant is negative, less than 0. That means here under the root, the square root, we will have a negative number. Well, square root of a negative number is not a real number. But that doesn't mean we don't have two solutions. We have two complex solutions, or complex roots, right? So that will happen if the parabola doesn't even hit the x-axis, if it's like this, or let's say like that. So it never touches the x-axis. So if the graph doesn't touch the x-axis, that means we don't have real solutions. But in the case of the quadratic problem, we can say still that we do have solutions. They are just complex numbers rather than real numbers. So what to conclude? Quadratic equations always have two solutions. Depending on what the determinant says, those solutions could be two real roots, that's when the determinant is positive, greater than 0. We can have double roots, that's when the determinant is equal to 0. And we can have two complex roots, that's when the determinant is less than 0, when it is negative. I hope you liked the video. If you did, please click like, click subscribe, and don't forget to smile.